but when we add water, what will happen to the concentration of the aqueous species? Like this guy.
Would it?
What is going to happen to these guys?
Would they be decreased?
Yeah, they have to decrease because you have more water now, the same number of moles as before. Therefore, they should decrease. Okay. So if you think about the kinetic argument, the Q is the products over reactants. In the products, you have H3O plus, H3O plus concentration, and then A minus concentration. Okay, and in the reactants, we have the HA concentration. Are you okay with me calling them HA and A minus?
Yes.
Okay,
Yes.
okay, perfect. All right. Now what's going to happen is, let me write this somehow. I'm going to use a different color. And okay, when you add water, it's going to decrease the concentration of H3O plus. It's going to decrease the concentration of A minus, and also it's going to decrease the concentration of HA. Do you agree?
Yes.
Now everything is decreased, but which will be impacted more, the numerator or the denominator?
The top.
The top, yeah, exactly. And as a result of that, the Q should be less than K, or Q should be greater than K now?
Less than K.
Yeah, there you go. The Q decreases now, right? And as a result of that, our Q value will be less than K. Now, if the Q is less than K, okay, that means, so I mean, if you think about this, here's my Q versus time graph, right? Everything was at the equilibrium the K value in the beginning. Okay, so everything was at K, when they are at the equilibrium, okay? But due to this perturbation, Q decreased, okay? Now what needs to happen is Q needs to get back up to K, okay, by producing more products. Do you agree? So Q needs to increase. For Q to increase, you need to increase H3O plus and A minus. Right?
Yes.
Therefore, more products are formed. Okay, products should be formed until let me write that actually. Products should be formed. I don't know. Anyway, you got it. P is formed until Q becomes equal to K again.
Yes.
Okay, since products are formed, it's going to equilibrium will shift towards the products, and also when you think about H3O plus, okay, it is true that the shift should produce more H3O plus, but the thing is, the decrease of the H3O plus concentration due to the perturbation is much greater than the shift. Therefore, overall H3O plus concentration decreases. Okay, therefore pH must increase. Now, it has to be between 1 and 2, and then between 1 and 2, only 1 is showing Q decreasing initially. Therefore, correct answer must be option 1. This is what I would go with.
Okay.
Huh? What do you think about that, Rod? I mean, any questions about the thought process here?
I don't know what I think, to be honest.
Anything that doesn't make sense to you?
No, everything makes sense.
Okay. Okay.
Yes,
Yeah.
everything makes sense. So,
yeah, let me clear my
I don't know what I thought at this moment, but anyway.
Can you submit an answer again?
I don't have a time.
Oh, shoot. Okay. I thought
so like so you extend the deadline, but you didn't allow attempt.
Oh, really? I meant to add an attempt. Give me a second. I didn't know that. I didn't add an attempt?
I don't have extra attempt.
That's okay. Give me a second. That's my bad. I was meaning to add an extra attempt, actually. Give me a second. All right. Let me put details. Oh, yeah. I just have 2 actually. There you go.
Okay.
Can you refresh now?
Oh, I think. Oh, yes. And my top hat is really weird, Dr. Pereira.
What's happening?
I couldn't scroll up and down to see it.
Oh God, yeah.
Yeah, it's so weird. So I had to like look and then kind of like this. It's weird. I don't know why. Maybe it's my computer. I don't know.
I don't think so. I mean,
It was.
It's about the website, right? I mean, there are sometimes they have some glitches actually.
Yeah. Correct. So you said this should be 1.
Okay, read the question again. So sometimes the versions change.
Oh,
okay. You gotta be careful. When more water is added.
More water added in.
And it's still an acid, right? Yeah, okay.
Okay, let's see. Yay. I think I did wrong a lot, so we can do it together. I think I was wrong on this one too.
Yeah, now you're gonna tell me what to do, okay? I'm gonna listen.
Okay.
Imagine
cool.
Imagine that I'm the student now, you're the instructor.
No.
Okay.
Okay. Okay. So this is a base.
Yeah.
It's a weak base, pKb. Which piece is the most abundant in quartz? pH equals 3.
Yeah, we haven't talked about this in class structure, to be fair to you, actually. You know that, right? Do you know that we haven't talked about it in class yet?
I did. I don't know. I didn't know that. I thought. Yeah, I thought. I thought we talk. I mean, we talk about pKb and pH and stuff, right?
True.
But we don't really talk about abundance.
Right. Right.
Okay.
Right. So give me a second. I need to. I'll give you some hints here. Okay.
Mm-hmm.
So what we're gonna do this week in the class is about Henderson. It's called the Henderson-Hasselbalch equation. We'll be using the Henderson-Hasselbalch equation to determine a few things like the abundant species and the buffer solutions and stuff like that. Right?
Okay.
So what it says is, okay, maybe you can Google this as well. I'm going to use my memory for the moment. So according to this, pH is equal to pKa plus log conjugate base concentration over weak acid concentration. Whenever we use the Henderson-Hasselbalch equation, okay, we have to use the acid form because it is what we have in this form. Okay.
Okay.
Are you with me so far, Prat?
Yes.
Okay. Now, what we can do is we can rearrange this. We can say log A minus concentration over HA concentration is equal to pH minus pKa. Do you see that?
Yes.
Okay. Now, if you want to find the A minus concentration over HA concentration, right, we need to get rid of the log. To get rid of the log, we need to raise everything to the power of 10. So it should be A minus over HA should be equal to 10 to the power of pH minus pKa. Are you with me so far, Kra?
Yes.
Okay. This is all we need. All right. Now, if A minus is greater than HA, conjugate base is dominant. If HA is greater than the A minus, the weak acid is dominant. That's the idea. Okay. Now let's think about this question. All right. You are given the pKa. Can you determine the pK? I'm sorry. You are given the pKb. Can you determine the pKa from this?
Yes. 14 minus 9.1, which is 4.9.
Okay. pKa is 4.9. Okay. Now your pH is given, right? What's the pH given to you?
Yes, a 3.
It's 3, right? So pH, is it greater than pKa or smaller than pKa?
In this case, is smaller.
Yeah, so here the pH is less than the pKa. Okay. If that is the case, if you go back to this above equation over here, let me have this in a box. We can just use that as it is. All right. So pH is less than the pKa. Therefore, what will be larger, the top or the bottom?
The bottoms.
Yeah, because you're going to have a negative number here, right? pH
Right.
minus pKa must be a negative number. That means you're going to have more of the bottom than the top. That means you have more of the weak acid than the conjugate base. Do you agree, Krak?
Yes.
Okay. And as a result of that, the species should be in the acidic form. The dominant species for this should be the acid form, not the base form. The acid form of a base is it should be, this is an amine. So the acid form should have one extra proton, therefore it should be NH3 plus. Do you agree?
Yes.
Okay, so that should be dominant. And also between OH minus and H3O plus, which species should be dominant?
H3O plus.
Yeah, because you have a lower pH, that means you have a higher concentration of H3O plus than the OH minus.
Okay. Okay. So it should be D.
Yeah, yeah. Let's see if Prophet agrees with us.
Yes.
There you go. Is it okay if I use this to post on our digital site, Truck? Do you mind?
Yeah, for sure. Yeah, it's okay.
I think people can use that actually.
Yeah. Okay. Yeah, I think I got all the abundance wrong.
Now we should be able to do this actually, right? Let's just try this.
Okay.
Use that previous equation, Truck. I mean,
I can do it.
Okay. Hands off.
I don't know. I don't know if I can do it. I mean, I will do it.
Yeah, let's give it a shot. Yeah.
Okay. So A minus over HA equal 10 to the negative pH.
We did not have a negative sign there, did we?
Oh, we don't.
Yeah. Yeah. I mean, yeah, we can write that, but anyway, I mean, I hear you.
But okay, never mind. I'm not calculus. Yeah. Anyway.
Yeah, you don't need that much math. You can just use the equation.
Yeah. How can I? Sorry, like I'm erase it, and now I don't know how I can.
You need to go back to draw.
Okay.
Then, oh, there
yeah, I got it.
Out.
pH minus pKa.
Yep.
Okay. So if you add 2.1 mole of the weak acids, which is like HA, pKa 3.2 to solution pH 7, which means then how which one under such condition. So pH is larger than pKa.
Yeah.
So
you plug that in actually, right, for this question, Truck. What is the plug that in? So replace the pH with 7 and pKa with that value.
Are you asking which one is more abundant?
Yeah, no, what I'm asking is for you to plug them in, right? So this should be equal to 10 to the power of
okay. 10 to the power of 7 minus 3.2.
Yep.
Is equal 6309.
Okay.
Around that.
So that means for every one, give me a second, okay? So for every one weak acid, you have 6,309 conjugate base. Do you agree?
Yes.
Okay. Now, which one is dominant there?
I know this. Just hang on.
Yeah.
The base.
Yeah.
The base. Yeah.
Yeah. Which is?
Which is F minus.
F minus. Yep. Yep. Yay.
Yay.
Yep. That's it. Pretty good.
Thank you. I think. Yeah, I think that's all I did. No. So this one I think I kind of guess. Yeah, this one I definitely guess.
Okay. So you just guessed. Okay. Do you have any?
No.
What do you know actually though?
So I know that this is the base. This is percent of abundance pH. Yeah, I don't know. I don't know anything.
All right, let's think about this, right? So again, what we have these, I know this is the base, okay, but every base has its conjugate acid, and every acid has its conjugate base, right?
Yes.
So again, this is all about the Henderson-Hasselbalch equation again, Prad. Okay. Now let's think about this really in a fundamental way, right? If you lower the pH, that means if you increase the H3O plus concentration, what form will be dominant? Let's say this is, we have HA, and then when it reacts with water, we're going to get, let me write that down anyway, because I started writing it. I hate writing because it's really hard to write with the mouse pad.
Yeah.
Anyway, we're going to get H3O plus A minus. Now the question is, right, if you add H3O plus, if you increase the H3O plus concentration, or if you, in other words, if you decrease the pH, right, this equilibrium will shift towards reactants or products?
Reactant.
And that will form more of the weak acid or the conjugate base?
The weak acid.
The weak acid, right? So in other words, if you have a lower pH, okay, this is how we read this graph actually, okay? So this region is a lower pH region relatively. I want black. Let me undo that. I want different color. Let's say this region is a lower pH region, and then this pH is a higher pH region relatively. Okay. So if you lower the pH, it is going to form more of HA. So the abundant species will be the weak acid.
Right.
Okay. But when you increase the pH, that means when you decrease the H3O plus concentration, let's say that this is our acid concentration in the beginning. Okay. When you increase the pH, this weak acid concentration goes down. Okay. And then at a certain pH.
Are you drawing or anything? I don't see anything.
Oh, you don't see it?
Oh, I saw it now. Okay.
Oh, okay. Okay. I'm sorry. All right. Yeah. So right. So the HA concentration goes down, and then the A minus concentration goes up. Are you okay with that, Trot?
Yes.
Because what I mean by increasing pH means I'm decreasing H3O plus concentration. When you decrease H3O plus, you are decreasing the product. Decreasing the product should form more and more.
Hold on. I'm sorry.
Yeah.
Yes.
Okay. Yeah. So decreasing H3O plus should produce more and more conjugate base. Yeah.
Yes.
Okay. Now that's how we read this graph actually. Okay. Now this graph has the percent species, actually in this case percent base in the y-axis. So now when you have 50%, I didn't draw this correctly, but anyway, when you have 50%, let me clear my graph. When you have 50% A minus, okay, that means this point. what will be the percentage of HA if this is about HA and A minus only drug? So the percentage here is about the percentage of A minus and percentage of A minus HA fulvic acid. Okay. Now if you have 50% of A minus, that means how much will be the percentage of HA?
Would it be 50% too?
Yeah, it should be 50% too, right? That means we have the same amount of HA and A minus. Yes?
Yes.
Okay, now let's go back to this, okay? If you can remember, what we have is, let me see, pH is equal to pKa plus log A minus concentration over HA concentration. Can you remember this equation, Prat?
Yes.
Yeah, this is the Henderson-Hasselbalch equation, right? Now, what we have at 50% A minus is A minus concentration must be equal to the HA concentration, yes?
Yes.
Now, if they are equal, that means A minus divided by HA must be equal to 1, yeah?
Yes.
What is log 1?
0.
Yeah, so if at that point, this part goes to 0. Okay, that means at 50% A minus, all right, or 50% HA, pH becomes equal to pKa. You see that? Because that part is 0. Okay, now what you do is you go back to the graph and then read the pH at 50% from the graph. It's somewhere on here. Okay, and that value must be equal to what?
pKa.
Yeah, pKa. Is that what they're asking? And you're asking pKb. Yeah, can you get the pKa first, Prat, from the graph?
Yeah, it's around 10 point something.
Okay, so let's actually write that down.
10.2.
Okay, so the pKa is, let's say, 10.2. All right, let's go with that. It's an estimation of course, 10.2. If pKa is 10.2, what should be the pKb?
It should be 3.8.
Yeah, 14 minus pK. You're really good. I think you're gonna do great now. 3.8. Yep. So that should be your answer. Is that 3.8 as an answer? Something like
Yes.
that? Oh,
Yay.
why can't you submit that?
Yeah, I submitted already. It said correct.
Oh, okay, okay, it's correct already. Okay.
Okay. Yeah.
All right. That's
That's
it.
a lot of thinking.
Yeah, a lot of thinking, but it makes sense, right?
Yes, yes.
Yeah.
Yeah.
But at this moment, I think we have covered everything you're gonna see on the test as well, Prak. So, I mean, you don't need to come to the lecture tomorrow, but I hope that you'll be there.
I will.
Okay, this is it. This is all. I'm gonna go over. I think the only thing that was missing here was about the buffer solutions, but it's a very small thing. I wonder why we don't have any buffer questions here. Did you see any buffer questions?
On the Wiz or
Like
you mean-
buffer. Did you see the word buffer anywhere? Like in
yeah, I do in the reading.
In the reading, not in the homework.
No, not in the homework. In the reading that due next week. Oh, that due not next week. I mean Wednesday.
Okay. Okay.
Yeah.
All right. It would be great if I can post this so that others can benefit to Prak.
Yeah, it's
Yeah.
okay.
Okay.
You mean like how do you post it? Like you mean screenshot?
So no, what I'm gonna do is, I mean, I'm recording this apparently.
Oh, are you recording right now?
Yes. Are you okay with it?
Do
Do you see it? You should be able to see it.
oh my gosh. It should have told me, but I didn't see it
You
say.
If you're not comfortable with
No,
me
I mean
posting-
no, I'm fine. You can post wherever. I don't care. I don't mind.
Okay.
I become famous. No, just me.
I can try to I mean, crop this video as well. It will
Yeah,
take a little
that's
more time, but I
okay.
can do it.
Yeah, like whatever is fine for me. I don't. Yeah.
Right, thank you, Prof.
Okay. Yeah, you're welcome. Mm, I think. Okay, let me share this.
Yeah.
How do I new share?
I think you do stop sharing first, and then
Do you see my new screen?
yeah, I see W7A. Is that?
Yeah,
Yes.
W7A.
Yes.
I did it correct,
Uh-huh.
but I have it in my screenshot. Like I have it like, oh, I screenshot it because I have questions, but now I don't remember like what is my questions.
Uh-huh.
I think like I used all the terms, which means I didn't get it correct the first time.
Uh-huh.
So let's see. It's mixed with, what is the pH of the mixture? Yes, yeah.
Give me your thought process, Prak.
So a solution with mixed with another solution. Oh my God, it's so loud.
That's okay. No, don't worry about it.
Yeah, it's just so loud in my background. So I know this is not correct, but I feel like it's like an acid with a base, and it will be form water.
That's true. It's correct.
Yeah, so that's what I think. And then you would you put down like the initial concentration, and then which is like more than, I don't know.
Yeah. So yeah, exactly. I mean, I think you got this, Prak. Actually, I mean, you said it. Okay. So I mean, you are adding more OH minus to H3O plus, right? So some of these OH minus will react with H3O plus, okay? But and then at the end of the day, we're going to have an excess of OH minus, all right? And that excess concentration of OH minus must be roughly equal to 3 times 10 to the power of minus 2 minus 2 times 10 to the power of minus 6. Do you agree?
Yes, I think that's how I did it.
Yeah, that is totally fine. All right. But here's the thing though. If you subtract, I mean, if you do this subtraction, okay, your value will still be around 3 times 10 to the power of minus 2. Don't you agree? Because you're subtracting a very, very small value from 0.03. So your value must be still 3 times 10 to the power of minus 2. Okay, essentially, yeah?
Yes.
Okay, now you have the OH minus concentration. If that is the case, can you calculate the POH?
Yes, it'd be 2. Around 2. Oh no, let me do the correct math.
Yeah.
About 1.5.
All right, let me write this first. Minus 2, and then you got about 1.5, right?
Yes.
Okay, 1.5. Therefore, what should be the pH then?
It should be 12.5.
Yeah, 14 minus POH. Okay, which is 12.5. Oh, shoot. Okay, we have 12.5 as the answer as well. So can you tell me the value what you get when you actually do the subtraction, Prak?
12.477.
12.477. Okay, 500 of this mixed with 500 solution of this. Okay, now here's the thing though. Here's what we did not account for. Okay, it is true that we are doing this, but the thing is the entire solution is diluted twice, correct?
Come back one more time, sorry.
So the entire, so initially what we had was 500, right? We are mixing 500 with 500, right?
Yes.
Okay, So now if that is the case, we are diluting everything by a factor of 2, correct? Okay, so do you see that we have 500 here, Truck?
Yes, I do.
And then if you mix 500 with another 500,
Okay, yes.
okay, now you have 1,000 milliliters. Initially you did not have. Okay, here's how you can, I mean, think about this in a different way. Actually, let me show you.
I think I get it. Like,
okay.
Yeah.
Okay, so your actual concentration must be then 1.5 times to the power of minus 2. Can you try that?
My what?
So your OH minus concentration is not 3 times to the power of minus 2, but half of that.
Okay, so it's 1.5 to the 10 to the negative 2.
Can we try that?
Yeah. So the POH would be 1.8.
1.8.
Yeah. And then so the pH would be 12.2.
Yeah, there you go. Yeah, 12.2. I'm glad that we made this mistake because I mean that's going to be a common mistake if you don't account for the volume, right?
Yeah.
Yeah. Okay. Okay. Nice.
Okay. Okay, cool. Yeah.
Let me get rid of my.
And oh my, I need to pull this up because I didn't like screenshot the.
That's fine.
WAA.
This is nice actually. So you finish all the homework questions, the reading assignment questions, and then the worksheet questions. And also whenever you have a doubt about any of these questions, you took a screenshot so that you can think about them and you can talk to me about them.
Yeah.
Yeah, I mean, I'm describing an ideal student here, Truck. I mean, you know, it's gonna make my job much easier if everybody has your commitment.
Oh, thank you. So it says which of these drugs is likely to have an equilibrium constant K larger than 1 when reacting with water? Let me see. Because it's none of them because all of them is weak, right?
That's right, absolutely.
Okay,
absolutely.
okay.
You cannot imagine how many students get this simple question wrong. Okay, so we know that all of these have pKa's and pKb's positive values, right? So pK can be 4 or pKb can be I don't know, a 5 or 6, something like that, right? So whenever we have a situation like this, for an example, let's say that I don't know, ibuprofen, let's say that the pK of this is, I don't know the value, okay, honestly, let's say this is 4. Okay, if the pKa for this guy is 4, okay, what should be the Ka value, Truck?
It would be 10 to the negative 4.
Yeah, exactly. Ka should be 10 to the power of minus pKa, that means 10 to the power of minus 4, right? And now this value is, now the only thing we need to appreciate here is this value is less than 1.
Yes.
Okay, if it is less than 1, it's going to be reactant favored or product favored?
Reactant favor.
Reactant favored. We forget this. This is one of the simplest thing. Surprisingly, many students miss this during an exam.
Yes. Yeah. So, yeah. Are you still recording?
Yeah. I mean,
okay. Never mind. Yes. Yeah. I feel that. I feel that.
All right, here you
go. Okay.
You're on the deck right now. Okay.
Okay, cool. Let's see. Yeah. So I think I have questions with. Yeah. So it will be we will use the equations that you showed me earlier, right?
Right. Yeah. So using an ibuprofen dissolved. Ibuprofen, is it an acid or a base?
Ibuprofen. Let me see. It's a different ibuprofen. Is acid.
Oh, okay, yeah, it's an acid, right? That means
Yeah.
in water you're gonna have more H3O plus, because that's the definition of an acid, than OH minus. So you're gonna have a less of OH minus, that's for sure. And then which of these species is the least abundant at equilibrium when 0.05 moles of ibuprofen are dissolved in water? Can you tell me your thinking, Prak, here?
Yeah, I was thinking the same. Like it's an acid, so OH minus should be the least abundance. That's why I simply think like
Right,
that.
right.
Yeah.
And then what about the conjugate base? Why isn't conjugate base yeah, I mean least abundant?
So are you asking why it's not the least
Yeah.
abundant?
Yes. Have you thought about it, Prak?
Yeah, I thought about it too. I thought so that well, like if I choose D and it's strong, then I go for B.
Yeah, I mean it's only one correct answer. Okay.
Yeah, but yeah, I'm not sure when I did it, but
Right. So let's think about this really quickly, okay? Now, now both this is our A minus, okay, and then this is our H3O plus, right? And this is our HA, right? And then obviously HA will be the most abundant because it's a weak acid. Okay, it's going to be a partial dissociation, so you're going to have a lot of HA left. All right. Now we know that there should be more H3O plus than OH minus, correct, Prak?
yes.
Which is an acid. Okay. Now, if we know the amount of H3O plus, do you know the amount of A minus?
Yes.
Yeah, because what we're getting it from the same source, right?
Yes.
HA dissociates into H plus. I mean H3O plus. I mean I omitted the water here. H plus and A minus, right? So
Yes.
if we have a certain amount of H plus, and that should be the amount of A minus as well. If H3O plus is not the least abundant, then A minus cannot be the least abundant. Yeah.
Yes. Yes.
Yeah. That's just making a point. Yeah. Get rid of my.
Okay. Yeah. Okay. I think I have one more. Run. W3B.
Did these have buffer questions by any chance? So
No, I don't think so.
okay. But you had enough practice though, right? I mean,
Yeah, I think I have questions for this one.
okay. This is a buffer question actually. Right?
Yes.
Yeah, this is what I was looking for. This is a buffer question.
Oh, this is buffer question. Okay.
Okay. Now tell me your thinking, and then let's go from there.
Okay. Prepare by Winona. I write down the reaction.
Right.
Do you want me to write down?
Yeah. So let's do this. Okay.
Okay.
Can you write the let's do the Henderson-Hasselbalch equation. I mean, can you write the Henderson-Hasselbalch equation?
Can I write what?
The Henderson-Hasselbalch equation, the first equation we wrote, pH is equal to pKa plus log A minus over HA.
Oh, yes. Sorry.
That's fine.
So it's pH. So you want me to write like the pH equal pKa plus?
Yes.
Okay. Oh my gosh.
It's hard to draw, right? I know. Now you know what I'm going through. You have to write. All right. Now we just need to plug and chug now. Okay. So first of all, can you find the reference if we know pK is this. Okay, so let's do this actually. Actually, this might not be the buffer question I was waiting for. But can you calculate the concentration of this species truck?
Yes, I can.
Yeah.
So we find a mole.
Yeah. This
Yeah.
is not the buffer question actually. I misspoke earlier. But we can still. It's okay.
Okay, so the mole is equal. And then divide. So I got the mole, and then I get the mole divided for 0.25.
Yep, that's right.
I got around 0.012.
0.012. So what you did was you divided 0.25 grams by the molar mass of CH3COONA, and then you divided that moles by the volume, which is 0.25 liters, right?
Yes.
Okay, and that's what you got, and it should be in molar. Okay, now this is your C note. You don't need this equation actually, Prak. I'm sorry. I mean, I was hoping for a buffer equation, but it is not. Anyway, now we have the C note of the base, and then do we know the KB?
Yeah. We know pKa.
We know pKa. Yeah,
So we can find BKB. Which is 14 minus 4.76 is 9.24.
9.24. Therefore, KB must be.
KB is 10 to the negative 9.24.
Yep.
Oh. This is really hard.
Right. I know. Yeah, but it's fine. Okay.
9.24. Okay.
Yeah, now we know that. Okay. Now, okay. So did you realize that this guy over here is the conjugate base of that acid?
Yes.
Okay, because I mean, when you dissolve, so it's called sodium acetate as well, right? When you dissolve this, what you're gonna get is CH3 COO and A completely dissociates into Na plus, Na plus, and CH3. I can write now. CH3 COO minus.
Yes.
Okay, and that's what we calculated here. Actually, we calculated the concentration of this guy, which is the conjugate base of the weak acid given to you here. Yes.
Yes.
Okay. Now we know the C note. We know the KB. Can you calculate the OH minus concentration?
Yes. So it'd be concentration times KB.
KB.
Negative 9.24.
Yep. Square root of that. Right?
And to the power of 1/2.
Yep.
I got 2.6 times 10 to the negative 6.
2.6 times 10 to the negative 6 as your
OH.
OH minus concentration. Okay.
Yes.
Can you calculate the POH?
Yes. I got 5.6.
5.6. Can you calculate the pH?
Yes, I got 8.4.
All right, that is 14 minus POH, right?
Yes.
Yeah, 14 minus 5.6. Yeah, I'm using it. There you go. That's going to be 8.4.
Okay.
Yeah. So now usually when we give you buffer questions, we have like sodium acetate and this setup in the beginning. That's why my mind went to the buffers actually immediately. But anyway, we'll get there.
Okay. Is that what we learn tomorrow?
Yeah, we're gonna at least start talking about the buffers tomorrow, and then maybe we will have to finish that on Thursday.
Okay.
Yeah.
Okay, cool. I have one answer. I don't know what is. Okay. What is the pKb of NO2 minus if solution prepares water? It could be similar, right?
Yeah, it's the same thing, right?
Okay.
NO2 minus is the conjugate base of HNO2.
Okay.
Yeah. Are you, what's the pKb? You're given the pH, right? If you're given the pH, then you can calculate, give me a second, okay? So you have the pH, we can get the pOH from here. Let me see. Let's see. If we can go this route, okay? There are other ways of doing it, and if you know the pOH, let's check the pOH. Actually, pOH is
5.76.
5.76.
Yes.
Okay, 5.76. Okay. Then the OH minus concentration is known, right? OH minus concentration is 10 to the power of minus 5.76. Yeah.
Yes.
Okay. Now we have the OH minus concentration, which is equal to C naught times Kb, right? The square root of it.
Okay.
And do you know the C naught, Prat?
Yes. Like here, right?
Yeah, we have 3 grams. If you divide 3 grams by the molar mass of NaNO2, you're going to get the moles of NaNO2, which is equal to the moles of NO2 minus.
Okay. Let me try. Is it pKb? So negative log.
What's the molar mass of NaNO2, Prat?
Oh, the molar mass. 69.
69?
Yes.
Okay. 69 grams per mole. Oh, I like this number. Okay, so you're gonna get
I got 0.04.
okay.
1/23.
Okay, moles. Okay. And if you want to calculate the concentration, you need to divide the number of moles by the volume, right?
Yes.
Okay, which is 1/23 moles divided by 0.2, yeah? Because 200 milliliters in liters should be 0.2.
Okay.
Yeah, what did you get, Ron? There should be a C note.
I got 5/23.
5/23. Yeah, I can live with that. More. Okay, so we know the C naught now. We know the OH minus concentration. Only thing that we do not know is the Kb, right?
Yes.
So let's do this again. So C naught times Kb should be equal to OH minus concentration squared.
Yes.
Do you agree?
Yes.
OH minus concentration squared. Okay, and then this should be equal to 10 to the power of minus 5.76 times 2, yeah?
Yes.
Which is 10 to the power of minus, I don't know, 11 point something?
11.52.
11.52, is that right?
Yes.
11.52. Okay, and is equal to initial concentration is known, 5/23, okay, multiplied by Kb. Okay, therefore Kb is the only thing that we do not know. Must be equal to, I'm going to move everything to the other side. 23 divided by 5 multiplied by 10 to the power of minus 11.52. Does it make sense, Trump?
Yes.
What did you get?
1.4 times 10 to the negative 11.
1.4 times 10 to the negative 11. Okay. Now this is the KB, but we need the PKB, right? So
Yes.
we will take the minus log of that. So PKB is the minus log KB. The minus, you know how hard it is, right? So 1.4 times 10 to the negative 11 should be 10 something. Oh,
Yeah, 10.85.
10.85. Yeah, I will go with that.